Hello, welcome back to Chapter 8, Section 2, Multiplying and Dividing Rational Expressions. We're going to do some examples with dividing, which are from the practice problems that are right before you do the homework problems, actually. All right, so again, when I multiply, I factor each numerator and denominator. I eliminate, cancel, reduce, whatever you want to call it, common factors, top and bottom, numerator, denominator. And then usually I want to remultiply, but I'm going to leave that out. We're going to do all that, but first we got to get it into multiplying. So we're going to multiply by the reciprocal. So all I'm going to do is I'm going to write this. That'll be the same. I'm going to change that to a multiplication problem, and I'm going to change that to its reciprocal. And yeah, I know that's keep, change, flip. But again, that's a horrible way of teaching it. You're multiplying by the reciprocal. So I'm going to combine steps by factoring, but when I factor, when I rewrite them, I'm going to also write it as reciprocal. So here's what I'm talking about. I'm going to end up with x to the fifth, y to the fourth. Okay, so 1, 2, 3, 4, 5 x's, dot, 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 dot. Y to the fourth is y times y times y times y. 3xy is 3 times x times y. Okay, now I'm going to change this to multiplication. I'm going to put the 1, now that goes in the denominator because I'm writing this reciprocal. X to the third y is going to be x times x times x times y. So I factored, and when I wrote my factors, I also did my reciprocal. Now I'm going to eliminate any common factors. Yeah, I know. Here's an x, here's a y. Doesn't matter which one you pick. All the rest of them stay where they're at. So how many x's I got? I got 1, 2, 3, 4, 5, 6, 7. X to the 7th power. How many y's do I have in the top? 1, 2, 3, 4. Y to the 4th power. And what's left? 3 times 1, which is just 3. Yeah, I know. I don't like it when they do that either. This one might be a little bit better. X plus 3. That binomial cannot be factored. This trinomial, what two numbers multiply to give a positive 1, add to give negative 2. That's x subtract 1 times itself, x subtract 1. You might see, and I mention this because I strongly recommend that you go and watch videos of other people doing this, including Ms. Corbett, whose YouTube channel I have linked, or if you want to go to Khan Academy. If you do that, they might write this x subtract 1 squared. I normally don't do that when we're like trying to cancel. There you go, I use the word cancel, trying to eliminate things, just because I think it's hard for my students to see. But there's nothing wrong with it. It's just, if you know it's there, it's fine. But anyway, your mileage may vary. All right, this x subtract 1 is in the denominator. Now I'm going to put it in the numerator, so that's going to flip. And same thing with the x plus 3. So that went there. Didn't have to factor either one. The x plus 3's, those are going to reduce. And the x minus 1's are going to reduce. Obviously, I got x minus 1 in the denominator. But what I got left in the numerator? Well, again, something divided by itself equals 1, not 0. So it's a 1. Just a little dry. Hang on. I think I'm out of water. Match that up for you. Okay. That's the difference of two squares. These are easier trinomials to factor. This is one I'm going to have to use my diamond method for. So I'm going to put it over here in the corner, okay? So, come on, marker. X squared subtract 25 is x plus 5 times x subtract 5. I'm going to do my times sign there. X to the 2nd power subtract 3x subtract 10. I'm going to factor it, but I'm going to put it down here. This is going to be x subtract 5 times x plus 2. So that one went there. X squared plus 9x plus 20 is going to be x plus 4, x plus 5, and that went there. So I picked them up to flip them, but while I was flipping them, I factored them. I did it all together. I got to factor that. I'm just going to come over here and do it. I just need some space. I could have grabbed a separate sheet of paper, but I had the space. 2 times negative 12 is negative 24. I got 5 here. That's going to be 8 and negative 3. Make my multiplication chart. I get 2x squared, 8x, negative 3x, negative 12. That gives me 2x. That's x and 4, and this will be negative 3. Double check. Yep, that all works. So I got x plus 4 times 2x subtract 3. Now I can eliminate. Here's an x plus 5. Nope. Here's an x minus 5. Yeah, that's going to go away. Here's an x plus 4. Yep. And here's an x plus 5. There's an x plus 5. But do that x plus 5 and that x plus 5, do they eliminate each other? No, because they're being multiplied, not divided. I have to have it one in the top and one in the bottom. Nothing else is going to be eliminated. So this becomes x plus 5 times another x plus 5 divided by 2x subtract 3 times x plus 2. Now, in class, we can take this to the next level and simplify it further by remultiplying these factors. The top is going to be x squared plus 10x plus 5. The bottom is going to be 2x squared plus x subtract 6. But we don't need to do that for our video right here. Okay, finally, problem number 14. Luckily, x squared, x squared, x squared, these are all going to be easy to factor. So the first one, what two numbers multiply to give 1, add to give 2? That's x plus 1 times x plus 1. What two numbers multiply to give negative 18 that add to give negative 3? That's going to be 6 and 3. That's right. X subtract 6 times x plus 3. Now I'm going to multiply. I'm going to take the x squared subtract 1, factor it into x plus 1 times x minus 1, difference of two squares, but that goes into the denominator. And the x squared subtract 7x plus 6, that's x subtract 6, x subtract 1, that goes in the numerator. So that goes there and that goes there because of the reciprocal. All right, now I'm looking for matching pairs top and bottom. Here's x plus 1, x plus 1. Here's x subtract 6, x subtract 6. And here's x minus 1, x minus 1. So when it's all said and done, I get x plus 1 over x plus 3. This is not 1/3. The x's do not reduce. Move that up so you can see it. So don't make that mistake. All right, we'll see you in the next video.